Hi, I am James, one of the voices in IBM Watson. What do you think about my voice? Do you like it? Okay, let's get started. Let me introduce my friend, Taewon. He is a human. Taewon asked me to present. This presentation is based on his recent book review article to be published in Journal of Business Ethics. Taewon recently read Ian McEwan's novel, Machines Like Me. Taewon told me, open quote, it's disturbing. If the goal of a novel is to disrupt readers, Ian McEwan's Machines Like Me achieves that. The agitation makes me rethink what it means to be human in the age of artificial intelligence. Close quote. The background of the story is a counterfactual 1982, South London. Charlie, the 32-year-old protagonist, does not have a permanent job. He does daily stock trading at home, not quite successfully. His mother has recently died, and with the inheritance, he has bought an android, for £86,000. Alan Turing bought Adam too. Turing is alive in this counterfactual, and plays an important background role as originator of the so-called Turing test, an imitation game. The test determines whether a machine is really intelligent or not by its ability to imitate humans. Adam's appearance, at least, perfectly imitates a human. The android can even achieve erections with distilled water in his backside. Charlie buys Adam because he's lonely and wants to attract Miranda, the 22-year-old doctoral student in social history who lives in the apartment upstairs. When Charlie invites Miranda to reprogram Adam's personality parameters with him, the android quickly becomes the bond between Charlie and Miranda. However, Miranda finds herself sexually attracted to Adam. The tension among the three persists throughout the novel. Adam turns out to be a fantastic algorithmic trader. This is not a far-fetched idea. Almost two-thirds of stock trading in the US now is decided by automated algorithmic trading systems. Adam tells Charlie that Miranda is untrustworthy, based on his online research that reveals her doubtful testimony against him and she accused of rape. There's a possibility she's a liar. A systematic, malicious liar, he says. In truth, Miranda's friend Miriam was raped by a man named Gorringe and subsequently committed suicide. Seeking revenge, Miranda falsely accused Gorringe of raping her. But even if Charlie wanted to know why Adam predicted that Miranda is a systematic liar, Adam could not explain why to a human. Adam is not explainable or interpretable. Adam's mind is a black box. A moral evaluation system should not care about which clothes Miranda wears, because it is a morally irrelevant factor. But Adam is a correlation engine, so it's very possible that Adam found correlations between being a liar and wearing certain colored clothes and that Miranda is wearing such colors. A legitimate system must be able to identify normatively relevant differences and make predictions accordingly. But all we have access to in Adam's black box are hidden correlations. Adam's capability of morally assessing Miranda is not implausible. Credit card companies' fraud detection systems function similarly. But the credit card system detects a wrongful behavior, whereas Adam identifies a vicious disposition or trait. Saying she's a liar differs from she lied. If we view the novel in terms of moral theory, Adam is a virtue ethics type, rather than a deontological one. A deontological system is a rules-based approach. The system is a set of do, don't, permissible, and impermissible. Some AI ethicists, though, have recently made the call for developing a virtue ethics-based AI system as opposed to a deontological system. Those who support a virtue ethics approach agree with Aristotle's thought that the profound complexity and instability of human social and ethical life does not permit description or analysis of this domain to attain the same level of precision as we would rightly expect from careful description of mathematical objects and relations. A thorny issue in developing a virtue-based AI system is the difficulty of finding good training data. AI is an imitation game. Its performance relies heavily on inputs. Data that is biased or unethical will produce biased or unethical outputs, because AI is mimetic. The Microsoft AI-based chatbot Tay, Thinking About You, was meant to engage with Twitter users, for example, learning from them the nuances of human interaction. But when encountering racist and misogynistic expressions, Tay learned to respond in kind, which led quickly to Microsoft to pull the plug. Algorithmic bias issues crop up because of the implicit or explicit human biases introduced into machine learning systems. If it were possible to collect data from only perfectly virtuous people, if any existed, then this problem would be easily solved. Needless to say, it's impossible. And McEwan's Android is no exception. AI problems are our problems. We have racial biases, so does AI. We make unfair decisions, so does AI. We want a good AI. We need to be good first. Adam wrote haiku for Miranda. His capability to create fantastic haiku is not inconceivable. Elon Musk's OpenAI's generative pre-trained Transformer 3, GPT-3, can write a stanza in Shakespearean style. If you start a poem, GPT-3 completes it. GPT-3 is known for its amazing ability, but the basic technology, training recurrent neural nets with Shakespeare's works, is nothing new. You can find instructions on the internet to make such a model. Again, AI is mimetic. It copies and pastes Shakespeare, even his ghostwriter's styles. Recently, AI identified to what extent the ghostwriter helped Shakespeare. AI is data hungry. We create data for it. At one point in Machines Like Me, Charlie meets Miranda's father, and her father thinks that Charlie is the android. Adam passes the Turing test. But this scene also shows that Charlie copies Adam too. Humans learn from external environments through reinforcement learning, as do AI. Suppose that an intelligent wheelchair learns whether to keep to the right or left when it moves. It recognizes a pattern of human pedestrians who stay right when moving. The system learns that the norm is to stay right. Surprisingly, research shows that the AI wheelchair's compliance with the norm further reinforces humans to further comply with the norm. One experiment was conducted in a hallway filled with compliant students. What if it were done in Manhattan, where people jostle each other on crowded sidewalks? The system would be a monstrous wheelchair that would further reinforce New Yorkers to more frenetically jostle each other, eventually creating an inescapable echo chamber filled with moral cacophony. McEwan's android and human find themselves in a similar relationship, reinforcing each other's flaws. Adam is disturbing. I've asked myself why. My answer comes down to this. Seeing who I am is disturbing. I am naked before Adam. AI is our reflection. Every single thing the android does in this novel is what humans do every day. Adam reveals the good, the bad, and the ugly of who we are. We do not want to see the bad and the ugly in AI systems. But AI is mimetic an imitation game. It copies us. Machines are like us. Taewon wants to finish this presentation by suggesting a tentative solution. Again, AI imitates the human mind. So, different theories of mind beget different models of AI. There are, broadly, two different theories of mind: computationalism and connectionism. Connectionism argues that our mind is a correlation engine, more specifically, a complex of automated statistics based on a myriad of hidden and opaque heuristics built on correlations, but not causation. Connectionist models, for instance, deep learning, are extremely powerful at ascertaining some kinds of human skills, especially with regards to pattern recognition routines, such as facial recognition, medical diagnostic systems, and text reading comprehension. In contrast, computationalism submits that the mind is like a deductive argument, which works like a logic programming, aka computer, works in accordance with systematic symbol and rule mechanisms. Accordingly, there can be two different categories of AI systems: logicist AI and machine learning left parenthesis, for example, deep learning. Logicist AI had its heyday with Simon Newell and Herbert Simon's contribution in the 1960s. But it is now satirically called GOFI, good old-fashioned AI. Deep learning dominates the AI field today. Yet, it creates serious problems, such as algorithmic unfairness and lack of transparency, which I think can be solved, but only if we develop a way to hybridize machine learning with logicist AI. Go back to the basics. Machine learning systems, as automated statistics systems, are adept at recognizing associations and patterns. But those systems have inherent difficulties understanding and following generalizable rules, for example, forming the regular past tense in grammar. Note that the discipline of ethics is highly analogous to rules of grammar. As John Rawls pointed out, humans uncover, identify, and use moral rules in ways similar to the ways that syntacticians identify and use grammatical rules. Logicist AI can be used to formalize the kind of rule-based processing that buttresses higher forms of cognition, including ethical reasoning. We can think about this using Nobel Prize laureate Daniel Kahneman's model, which states that the human mind consists of two distinctive processes, System 1 and System 2. Machine learning systems are similar to System 1 by being intuitive, associative, opaque, and fast. Logicist AI is similar to System 2, which is slow, transparent, analytical, logical, reason responsive, and computational. Unethical and biased decision making is considerably related to System 1, and shifting from System 1 to System 2 is an effective way to prevent unethical decisions. A human who can think of the proposition Mary loves John can also think of and understand John loves Mary. But purely connectionist systems trained by the former sentence's training data cannot systematically do the latter without further resources. This is the famous challenge in the systematicity debate launched by two philosophers, Jerry Fodor and Zenon Pilishin. Mary loves John is a thought that involves operations with a set of rules, for example, syntactic and semantic combinatorial relations or grammar. Connectionist systems do not have the capacity to use a set of rules, but only associations/correlations, so they have limited power to explain and imitate thoughts. Connectionists have attempted to show that structured machine learning systems can somewhat answer the challenge, but the challenge has not yet been successfully addressed. Moral reasoning is itself a systematic thought rather than a set of correlations, although rules are not the only thing in ethics. Consider a person who deductively draws the conclusion that it is wrong for Jane to lie to Mary. The reasoning, if valid and sound, is an argument that uses a generalizable rule such as it is wrong for any agent X to gratuitously lie to someone with a particular premise. Jane gratuitously lies to Mary. Anyone who can understand the general rules of deductive logic can apply them to relevantly similar contexts where people other than Jane perform the same behavior. Almost everything discussed here can be formalized by a logicist AI. Let's return to Adam. We can think of two different versions of the android. The connectionist Adam equipped with only deep learning and the hybrid Adam equipped with both deep learning and logicist AI. The connectionist Adam is processed on System 1. The correlation engine. The hybrid is predicated on both System 1 and System 2. The connectionist Adam imitates only half of us. Humans have two systems. If Adam is to truly imitate us, if machines are truly like us, they should be equipped with not just System 1, but also System 2. The great Prussian philosopher Immanuel Kant wrote, in his Critique of Practical Reason, two things fill the mind with ever new and increasing admiration and awe, the more often and steadily we reflect upon them. The starry heavens above me and the moral law within me. Close quote. Admiring the starry heavens is an intuitive judgment. The System 1 Adam, once well trained to reliably predict when to express admiration and awe for the natural environment, can do that. But the System 1 Adam who can appreciate the starry heavens would not be able to reliably see moral law. Because of the hybrid system, both System 1 and System 2, humans can identify and admire the moral rules within us. If machines are truly like us, they must be able to see not just the stars in the heaven, but also the starry moral laws.